Hello guys. So today we are going to study KMP. Basically, this is used when suppose if we want to find a matching string in a matching pattern in a given string. So let me give you example. Suppose the given string is A C A A B Y. Okay, and the given pattern is A, A, A. Okay, suppose this is what we want to do. So pattern is given, and we need to find like in how many places it is coming in the given string X. So for example, if we start matching, so there are multiple way. So one is like a brute force, so which takes O n into m time. Okay. So what is O and m time? I will explain you. Where n is the size of X input array and m is the size of a pattern. Okay. So in this, what we do? So okay, just let me. Yeah. s- Yeah. So in this, what we do? We just keep on moving. Okay. So suppose we have this. Okay. Okay. What happened? Let me one second. Yeah. So we have this, and see, now we are here. C. It is not matching. Then we will just suppose we are going from x equal to where I equal to 0 to n. Then for I equal to 0, we match and it is not matching. Then we will go ahead, and this is also not matching as A or C is not matching. Similarly, we will go ahead. It is again not matching A and C. It is again, it is not matching. But here we get the first. So I will be 0, 1, 2, 3, 4, I equal to 5. Similarly, I equal to 6, I equal to 7, 8, not till 7 only. So from I equal to 5 to I equal to 6, 7. So we get three input where it is equal to the given pattern. So our answer will be 5, 6, 7. Okay. So this is what the answer is, and this will take O and M time. So this is a bit uh, uh, higher time complexity. So we come up with a solution which can work in uh, given time, O and time, that is linear time. So for this, we have other solutions like KMP model is there, rolling hash is there. So these are the model which help us in identifying the pattern in given string in linear time. So today we will read KMP algorithm. Okay. So uh, uh, KMP algorithm is based upon two things. First thing is LPS, and then second, compute answer based upon LPS. Okay. Now what is LPS? So LPS is largest prefix suffix. Okay. Now we want to calculate LPS of a given string. So if given string is suppose A, then what will be the LPS? Okay, let's see. And also one more thing, in this we don't take care of the entire string is not valid. Okay, since suppose A is a entire string, A is an entire string. That is not valid. We take one size less. Okay. So for A, first element, since it is only one element, and we will take one element less than the given string size, which is 0. So we cannot have any LPS, like largest prefix suffix. Okay. Now we go ahead and we have now double A. So for double A, the prefix is A and suffix is A. Okay, so largest prefix suffix is 1. Now let's go to triple A. Largest prefix is double A and largest suffix is also double A. So this is the largest prefix suffix possible. Now, what is for this? For fourth time A. So this is largest prefix and this is largest suffix. Okay, 3. I will tell you why we are calculating LPS. Okay, first you learn how to calculate LPS. Okay, so what we are doing, we are using this, we are capturing what is the largest LPS for each element of the pattern. So whatever the pattern is there, we are calculating its LPS. So this is the LPS for this. Okay. I will give you the code. Also explain you the code, like how it is done. So uh, and that will come after. But just first of all, let's understand how it is going. Okay. Now after this, we have put the LPS. Now let's come to the X, the given input. Okay. Okay. So in this, we will start from I equal to 0. And if we found a match, then we will, and I is for X and J is for the pattern. Okay. So see, first when I equal to 0 and J equal to 0, then A is matching. So we will increase I equal to 1, J equal to 1. Again, it matches. So we will increase I equal to 2, J equal to 2, which is also matching. Now, I equal to 3 and J equal to 3 not matching. Okay, now what to do if it is not matching? Okay, so let me one second. This is the element and this was our pattern, and here it is not matching. Okay, so since this is not matching, what we do? We move ahead with I. Okay, so this is our 4 element now, and we will match this 4 element with this 4 element. Okay, so now our input is AACA and it's AAA 4 time A. So in brute force, again we should start from I equal to 1 and J equal to 0. But since we are optimizing it, we will not do this. Okay. Now here, this LPS, largest prefix suffix will will come to help. See, this is a pattern. Okay. Once this is a pattern till the time we have till it was matching. Now since we have to go ahead one step because it has not matched here, that's why we need to move ahead. That's why what we will do, we will leave one element. So since this was matching, right? So and we are going one right means we have already calculated something for this. Okay, this second part, which is a suffix. Okay, remember. Uh, so yeah, what was the element? It was the element, or till this time we have already matched. Okay, now we are going ahead. We are going right. So what is left? The previous pattern which we have made, its suffix is left. Okay, so what we will do, we will check if this suffix is equal to the prefix of the pattern. Okay, so this is the so that's why we had calculated uh, the largest suffix prefix of this pattern. Okay, so till this point it was matching. So what is we have 0, 1, 2, 3 largest suffix prefix. So as per this, 2 is the largest suffix prefix till this means prefix of the prefix of pattern is matching with suffix of input string. Okay, so this index will give that value, that like what is the largest prefix suffix. So for this case, since it is not matching from here, that's why this is giving that input, that is 2. Okay, means since we have moved to right, like A, and it's A. So this 2 is saying that uh, till length 2, it is matching. Means you don't need to check for length 2. So what we will check? We will check the third element now. Since this is giving length, okay? Length of prefix suffix, okay? So we will check for third element. What is third element? Third element in array is j equal to 2. So it's 0, 1, 2. We will check C with A. Again, it is not matching. So we will follow the same pattern. Okay. So this will go ahead once more. Means it was AACA. Now it will be ACAA. And this will be pattern will remain same. But in this case, uh, till this point, it is not matching. So now we will check for this. It was 0, 1. Now j equal to 1. J equal to 1, in the previous case, not j equal to 1, sorry. Length equal to length of LPS. LPS equal to 1. So this is the size of LPS which is there. Okay. Now LPS equal to 1. Okay. What does this mean? Means j equal uh, means largest prefix suffix is of size 1. So we will check for the second element. Okay. So what we will do, it's ACAA, AAAA. We will check for second element, not matching again. So now it will again go ahead now, right side. Hence it will become now CAAA and pattern is AAA. Now LPS of this. Okay, since it is not matching, now we will check for this. It will be 0. Okay, so now LPS is 0. So J equal to also 0 for first element. Okay, and for J equal to 1 for second element. Okay, J equal to 0 for first element. We will check it is not matching. So now we will increase I plus 1. Okay, I will increase now. And we will get input A and A. So again, we will go same way. I plus 1, since it is matching, we will keep on going till it is matching. And since now j equal to length of pattern, means we have got the solution, and we will store it in an array. Answer equal to store it in array in the answer. Okay, same way, like you have got the concept now, like what's the use of prefix suffix. Okay, so prefix suffix is helping us when we are moving toward the right. Okay, so it is helping us in getting that index which is equal to the length of the suffix of the matching string and length of the prefix of the pattern. Okay, so let me try to get this again. So since see, we are starting from AAAA, the pattern, and the input is AAAAC. Till it this point, it was matching. So no issue, we were increasing I and J, but at I equal to 3, J equal to 3, it was not matching. So now we were checking this one. So now this is not matching. So we need to check this one now. So what we will do, so practically we have moved one step toward the right. So since this was matching A. So we checked its suffix and prefix, which we have saved in the LPS algorithm, and checked what is the maximum LPS they are supporting. What's the maximum LPS, like length of the prefix suffix, that for this it was 2, means these two prefix is equal to this one. So we need to check for the third element. Okay, so this was a case where we have the LPS. Let's suppose have a example where we don't have a LP. The LPS are 0. When okay, let's suppose input string X is ABCX, ABCY, and ABCDK, and pattern is ABCD. Okay, now the it LPS of all of them will be 0. Okay, so in this case, we start to match I equal to 1 ABC till ABC, it is matching. Okay, now for J equal to 3 and I equal to 3, not matching. Okay, so so now till this point we are checking, and it is not matching. Okay, so now uh, s- what we will do, A, B, C, X, A, B, C, D. Okay, it is not matching. Then we will check for the LPS of this one, which is 0. That is what is stored here. 0 means we need to, there is no LPS is there. Like, so we need to uh J equal to 0, means we need to go check for the J equal to 0, because LPS length of the height maximum prefix suffix is 0. There is no prefix suffix, it is not there. That's why J equal to 0, I equal to 3, means it will be X, A, B, C, and A, B, C, D. But here also it is not matching, so we will increase the I equal to 1, and the new input will be A, B, C, Y, and A, B, C, D. So again, it in the same way it will go. So that's how LPS is helping us. Okay, length of prefix suffix. Okay, now uh it's okay. You have got now how to calculate LPS. Okay, so I will help write the code for that. So main thing in calculating LPS, yeah, main thing in calculating LPS is that we need to uh, store the previous LPS, and from there we need to calculate, okay, what is the answer. Like, let's suppose, for example, it's A C A. Okay, so in this case, it's 0 1 2, and it's 0. Yeah, because we are checking 1 2 3 3. Okay, this is the answer. But yeah, like how we are getting that. Let's look into that. Okay. So we will start from suppose j equal to 0. And as we know, for first element, j equal to 0, it will be 0 only. Okay. So I will write, let's write a pseudocode. Okay. So let's have one LPS array, okay, of size m, where m is the size of this pattern array. And let's have two input. One is I equal to 0, which will traverse this pattern array, and then one will be uh, previous LPS. Okay, this will store the previous LPS. Okay, and suppose for I equal to 0, what will the previous LPS? It will be 0. For first element, it's always 0. Then let's start I equal to from 1, because we already know for I equal to 0, LPS is 0. And then from I equal to 1, we will calculate the LPS. Okay. And now let's see. So while I is less than what, n. Okay. For that time, if let's name arr I equal to arr previous LPS. Okay. So what we are checking, if we are checking if the element is equal to the previous element. Okay. I will explain you a bit. Okay, so if this is the case, then we just increase the length of the s- prefix. Okay, so length of the LPS will be +1. Let's see, for example, suppose we have, okay, AA. Now for A equal to 0, it's 0. Now we check for I equal to 1, and array of previous LPS, which is 0, is 0, is matching. Okay, AA. That's why now LPS for this will be previous LPS +1, that is 1. Okay. Now this is the case, and we will, since it is, we have gotten, we have increased the size of the LPS. So let's increase the size of the LPS here also, and let's move to new index. Now, else when it is not matching, there will be a chance it is not matching. Okay, in that case, we have to do two things. Check if previous LPS is equal to 0. Since we are storing LPS, it can be suppose C is there, then it can be 0 also. Okay, right? So for 0 case, we need to handle it carefully, and or else do some calculation. Okay. So if previous LPS is 0, in that, what does that means is it is not a there is no chance of having a common prefix suffix. Okay, and then I less equal to 1. Else, in else case, uh, previous LPS equal to LPS, previous LPS minus 1. Okay, now I will explain you what's going on here. Okay, so let's suppose we are starting A, A, it matched. We increase the previous LPS equal to 1 and I equal to 1. It is again matching. Previous LPS equal to 2 and I equal to 2. Now I equal to 3 and it is not matching. Then we come to the else. Is it equal to 0? No. Previous LPS was 3. Then what we are doing? We are doing previous LPS equal to LPS of previous minus 1. Matlab LPS of 3 minus 1 because we were at 3. It's LPS of 2. Now, this is the important why we are doing this. Okay. So it's 0, 1, 2, 3, 4, 5, 6, 7. So we were at 3 and it is not matching. This one is not matching. Okay. So now we need to go ahead. Okay. So what here we checked if it was 2. So we checked if it's possible to make it 3. It is not possible. Okay, it's not matching. So now we ask to this person, like, is it possible? If it's not possible to have 3, then is it possible to have 2? So we will check with a previous one. So what does this do? It that's only if it is not matching, then what we are doing? We are doing previous LPS minus 1, 3 minus 1, 2 LPS 2. LPS 2 is equal to LPS of 2 is 2. Okay, it means previous LPS is 2. Now we are checking for 2. We have checked if it's possible to have 3 LPS, means longest prefix suffix, but it is not possible. So we are checking for is it possible to have a 2 as an LPS? So to have a 2 as LPS, what is the case? Like, okay, for LPS to have 2 means AC should match to AA, right? AA is matching, so we should check for A and C is matching or not. Okay, we check it is not matching. Okay, then we again come to the else case and we said, okay, LPS is not 2 minus 1, which is 1. And in 2 minus 1, 1 means now we are checking for if it's possible to have 1 as a size of the LPS. 1 means if A is equal to C, but that is also not the case. That means LPS of this is 0. Okay, so I think you have got the idea or intuition why we are doing this. Okay, so we are checking step by step if the previous if LPS is possible or not. Okay, so how first we checked like we were moving continuously and now it is not equal to 1. So we were checking if it is possible to have a 2, 3 like that kind of thing. Okay, so 3 was not possible. So we checked if the previous was possible or not. So previous is this one, and in this 2 is stored. Means we are checking if length of 2 is possible or not. Means this 2 is possible or not. But this is not equal to this prefix is not equal to this suffix. Then we checked step back, one step previous, which is previous equal to 1. And here we checked. Okay, then here also we see that A equal to and A is not equal to C. Hence, the longest prefix suffix is 0. Okay, now let's move ahead in this only so that you get a better idea. C, A, A. Okay, in this case, it's 0, 1, 2, 0. Now it's 0. Okay, what does that 0 means here? Means previous LPS is 0. We will now I equal to 1, 2, 3, 4. I equal to 4 and previous LPS is equal to 0. Means previous LPS is this here, pointing here, and I is pointing here. So it is a match. A is a match. So it will be 1, and I then previous LPS also increased to 1, and I equal to 5. Again it is matching. Again it is matching. Okay, so matching, then it will be increasing. Now, here one more thing you will see. Now, A and C is not matching. Okay, so this is the point it is not matching. Okay, 5, 6, 7. Now, what it's not matching, and the previous LPS was 3, right? So, no, yeah, previous LPS was 3, and we were checking if 4 is possible or not. And what we find that A and C is not matching means 4 as a LPS not possible in this case. So we will check for one lower. Okay, what is the LPS for that, which is 4 minus 1 LPS of 3. Okay, previous LPS is 3, and here we see it's ARR. Okay, no, it's ARR 0 because this is not possible. So here we are doing some mistake. 1 second. So here we LPS 3. Okay. Now we were checking for LPS 4. Okay. ARR 4 and ARR I. ARR 7 equal to ARR 4, which is not there. Then we come here, and our previous LPS, which is 3. Okay, previous LPS is not 4, it's 3. So 3 minus 1. LPS equal to 4 is not possible because it is not equal to, or else it would have been. But for now, its previous LPS is 3. So we are doing subtracting 1. So we are checking LPS 3 minus 1 means LPS 2. LPS 2 is 2. Okay. So LPS 2 is saying, okay, like two size of prefix suffix is possible. You can check for one more if it is equal to. Okay, then we will check ARR 2 is equal to ARR, no, ARR 7 equal to ARR 2. Okay, then we store RR 7, 2 plus 1, 3 into the input. Okay, I hope you get this because this is a bit tricky one. Like to get this intuition why we are doing this. Okay, we are doing this just to identify what is the previous LPS possible. Okay, what is previous LPS possible? Okay, now I will also have one more example. I hope this is clear because what I can think of, I think I have explained it correctly. Now let's have one more example. A, B, A, C, A, B, A, D. Okay, so let's see how this will go. 0, 1, no, 0, 0, not matching. Okay, 0, 0, 1, 1 prefix suffix possible, 0, it's 1, 2, 3, and it's D now. Okay, don't not let's not keep it D. Let's keep it A. Okay, and then it will be 1 again. Okay, I hope now let me explain you how it is happening. So it's clear 0, 0 is clear because there is no prefix suffix possible here. Then here we see 1 is possible AA, and here again there is no possibility of any prefix suffix. Okay, now suppose this is a string in the C, 1 is possible. Okay, AA is matching. Now similarly we are as we can see AB is possible, ABA is possible. Okay, that's fine. Till 3 it is fine. Now uh how we get 1, this is a really good question. Now we check if C and A is not matching. Okay, so it is not possible to have it 4. What was the option? We have reached to till 3. We wanted to check for 4, but it is not matching. So 4 is not possible. Okay, so now previous LPS was 3. So we just check for LPS 2. Means we are asking कि भाई तुम बता कि brother tell me what is the maximum LPS is possible for this substring. So it is saying only one bro. Hence till this point we are here and we are it is not matched. So we are asking what is the size of the LPS you have. It is saying only one bro. So okay, you got it one means only one is the LPS till this that point. Now, what is the solution? Either it can be 2, okay, or 0, depending on what is stored here. Okay, so 1 is the solution. So we check for the 1 is possible. So we put a second element. Okay, means I j equal to 0, 1, 2, 3, 4, 5, 6, 7, and previous LPS equal to LPS 2, which is equal to 1. So it is saying 1 is possible, you can try for 2. So what is the second element? Second element is ARR 1, is previous LPS. We check and it is not equal to. Then we say, bro, it is not equal to. Then we check for 0, means previous LPS equal to LPS 1 minus 1, which is LPS 0, which is 0. And we see age equal to A. That's why for j equal to 7, it is 1. Okay, I hope this is clear now. Like how the intuition of this, mainly this line, like this line is storing the the possible LPS till that point. Okay, that's why when we are at this, it is saying, okay, 1 is possible, you can try for the second element. The second element is equal to previous LPS. Okay, that's why we tried for the second element and it is not equal to that. That's why it is saying, okay, then you can try for this one, which is 0. That's why. Okay, I guess this is what it is. And that's how we do LPS, and that's how we solve a KMP algorithm.